Hello everyone, welcome to Target45. My name is Jyoti. Today, as part of Day20 Coding series, we are solving these two patterns. The moment you see this pattern, it is very clear that this is a factorial triangle pattern. This is the first pattern we are going to solve today, and the second pattern is alternative factorial pattern. So we have covered about factorial problem as part of Day 4 coding series using two approaches, iterative and recursion. If you have missed this, please go back and complete this and come back to here. You will understand better. And if you have missed any of the coding problems from day 1 to day 19, please complete it. These problems are helpful for you for coding, programming, exams, and logical thinking. So, at first, understand what is factorial. Factorial is the product of all positive integers from 1 to the number. This is the factorial. It is defined as n factorial like this. So let's solve the first pattern. Today we are solving factorial problem using iterative approach. So I'm writing factorial underscore iterative. So I'm using this approach. If you want recursion approach, please go back to day 4 and cover it. You can easily understand. So at first I defined a function which is factorial underscore iterative, and I'm passing n parameter, and I'm checking the first condition, that is if n is less than 0, then we have to return factorial is not defined for negative numbers. This is the first condition we need to check here. If this condition is not satisfied, it is clear that it is a positive number. So in that case, we have to take result equal to 1, and we need to write a for loop from 2 to n plus 1, because we are taking the result as 1 and multiplying this result with every I in this for loop. So result equal to result into I. This is same as result into I. This line is same as this. It is up to you to use whatever you want. So after this for loop, we have to return the result. Let's call this function let's call this factorial function and see if it is working as expected. I'm passing 5 here. Let's see how it works. Okay, I'm not printing. Let's check. Okay, this is working correctly for 5. What if I give -1? It should return factorial is not defined. Good, it is working. What about 0? When we check factorial for 0, it is 1. Okay, this is working as expected. Now let's solve the pattern 1, which is this. So let's write another function which is factorial underscore triangle. I'm passing n as a parameter here. Since we have 5 rows here, if you see, there are 5 rows, and in each row, in the first row 1 is printed, and the second row 1 2, and the third row 1 2 6. So we need to use 2 loops for this. So I'm writing for I in range 1 to n plus 1. So it has to stop at n plus 1. So it will print up to n. And for j in range 1 to I plus 1, print. We are calling factorial underscore iterative function here. We have to call it j times, and we have to give end equal to this, because we have spaces in each pattern. If you see, for these spaces, what I am doing, I am simply giving, after printing each number, after getting this factorial underscore iterative of this number, I'm giving space, so that we'll get the pattern as expected, like this. So, and for every inner loop, we are taking the range from 1 to I, so that we get pattern like this. So let's run this, and after this we have to give one space after the inner for loop. After the inner for loop, we have to go to the next line for next I. Let's say for I equal to 1, we have printed this first row, and after the first row we have to go to the second row. For that we have to give print here, so that it will go to the new line, and now I is incremented to 2, and it will again print the pattern, and again it will go to the new line. So that is why we are using print here. So let's run this and see. I'm passing 5. Let's see. Okay. Factorial underscore triangle is not defined. Okay. Again, the problem is with the function name, and let's print. Okay. Let's call this away. Let's run this away. See, this is working as expected. So this is the pattern, and this is the one we got. So this is working fine. You can increase the n parameter here. Let's say for 10 we'll see. It will be the big one. See? So that is how we need to use it. So let's have 5 only here. For this pattern, if you see this pattern, it's very clear there. So let's take the indexes 2, 3, 4. So if you see, for every even index, it is printing as positive factorial, and for every odd index, it is printing as negative factorial. So let's solve this. So again, I am defining one more function, factorial underscore alternative. I'm passing in here. We have 10 rows. If you see here, we have 10 rows, and we need to write a for loop for I in range n, and we need to check the condition. If I modulo division 2 equal to 0, we have to print factorial underscore iterative I. We are calling factorial underscore iterative function in each of this pattern. If you see, this is the factorial underscore iterative function, and we are calling every time to get the factorial of the number if the index is positive and even, else if the index is not even, then we have to print the negative factorial underscore iterative I. So let's call this function. We need to call this function in order to run this. We pass n here. Alternative spelling is correct. So let's see if we get what we are expecting. So this is the one we got, and this is the expected. So this is working as expected. So in this way, we have solved two patterns. One is the factorial triangle, and the other one is the factorial alternative pattern. Here in this pattern, if you see, we have covered the functions, we have understood functions. In the previous coding series, we understood that function is something, function is a block of code which only runs when it is called. Here you can see more than that. Functions also provide reusability, modularity, abstraction. So functions also provide these particular features, which are reusability, modularity, abstraction, and avoids repetition. So why reusability is, we are just defining a factorial underscore iterative function here, and we are reusing it in two of the patterns, and we are calling it every time we need to find the factorial. That is why we are reusing this function every time. And the modularity is something we are breaking a large problem into simple pieces, and we are solving it with the functions. If you see, this pattern is one problem and the factorial is another problem. We have simply separated it into two pieces, and we break down into two pieces and we are solving each separately. So that is why it is also helping us in providing modularity, and it is providing abstraction also. Abstraction is something which means hiding the complex logic behind a simple function call. If you see, this is not that complex logic, but if we think of a larger scale, we are covering this complex logic under a simple function name. So that is how it is providing abstraction also, and it is avoiding repetition. Repetition is something we are not using factorial code again here in this factorial underscore triangle. We are not rewriting the entire code here. Instead, we are just making a function call. That is why it is avoiding repetition. So in this way, we have solved two patterns using functions. Understanding functions is very important. Mm, that's it for today. If you have any doubts or if you have any other suggestions, please comment in the comment section. That's it for today. Thank you.